For centuries, we've had these amazing tools, language, math, logic, to try and figure out the world. But what if there's an even more fundamental code running underneath everything? That's the mind-bending idea we're jumping in today. The idea that everything, and I mean everything, from the very fabric of space to where AI is headed, is all powered by one single thing: computation.
And we're not just talking about a new tool here. No, this is a whole new way of looking at everything. Stephen Wolfram's big idea is that computation isn't just something we do on our laptops. It's what the universe is. It's like we've found the ultimate source code for reality itself.
Okay, so to really get our heads around this, we're going to take a journey through 5 huge ideas. We're going to ask some pretty wild questions, like how is space itself actually built? Where do the laws of physics even come from? Why does time seem to only move in one direction? What's the real threat with AI? And, at the end of the day, what does this all mean for you and me?
All right, first off on our tour, let's start by, blowing up our most basic assumption about reality. We all kind of think of space as this big empty box, right? And all the stuff in the universe is just floating around inside it. But what if that's completely backwards? What if the universe isn't in space? What if the universe is space, actively building it moment by moment?
So if you could zoom in, like all the way down to the most fundamental level of reality, it's not a smooth, continuous thing. It's actually made of these tiny, discrete bits. You could call them atoms of space. And they're not defined by what they are, but by how they're connected to each other. And out of this giant network, and just a few simple computational rules running over and over, that's where everything we know, space, time, all of it comes from.
And this is where it gets really, really cool. Because this one idea might just solve the biggest puzzle in modern physics. It seems to unify gravity and quantum mechanics. The two theories that have never played nicely together. It suggests they're just two different views of the same thing. The structure of this physical space network, that's what we experience as gravity. And the structure of something called branchial space, which you can kind of think of as the space of all possible quantum futures, that's where all the quantum weirdness comes from. It's all just one big computational process underneath.
Okay, but hold on. That brings up a massive question, right? If our universe is just one possible computation out of zillions, why are our laws of physics so consistent and orderly? Well, the answer is a trip. It turns out the laws of physics we see might not be some universal absolute truth. They might just be a side effect of, us.
To get this, we have to introduce a concept called the ruliad. So what is it? Just imagine the ultimate abstract object. It's what you get when you run every single possible computational rule, forever. It's everything. It contains every possible universe, every thought you could ever have, literally anything and everything that is computationally possible.
But here's the catch. We can't see the whole thing. No way. It's an infinite, chaotic object. So instead, our minds, our human consciousness, we can only perceive a tiny little coherent slice of it.
So what defines the slice that we get to see? It comes down to 2 simple facts about being human. First, our brains have limits. We're computationally bounded. We can only process so much information. And second, we have this deep-seated belief that we exist continuously through time, right? That there's a consistent me from one moment to the next.
Now just think about what that implies. It's incredible. These 2 limitations, our finite minds and our experience of time, they act like a filter. They take the absolute, infinite chaos of the ruliad and they force it into a shape that we can understand, something that looks orderly and predictable. So the laws of physics, they're not some objective thing out there. They're a reflection of our own limitations as observers.
This computational view doesn't just change how we see space, it completely flips our understanding of time on its head. For centuries, science has had this dream, right? Find the perfect formula, plug in the numbers, and predict the future. Well, this new model says, that dream is impossible, by design.
And the reason why it has a name, computational irreducibility. It's a really important idea. It basically means that for a lot of systems, there's no shortcut. There's no clever formula that lets you jump to the end. The only way to know what the system will do is to let it do it. You have to run the computation, step by step.
And isn't that just a brilliant explanation for why time feels so real, so unstoppable? The passage of time. That's just the universe grinding through its own irreducible computation. The universe itself can't skip ahead to the answer. It has to do the work to get to the next moment. And so do we. We literally have to live through the steps. This table really helps put this all into perspective, showing how our models of the world have evolved. Way back in antiquity, it was all about what stuff is made of. Time was basically static. Then, around the 1600s, the mathematical age began, and time became just another variable, a coordinate and a formula. Then in the 80s, we started to grasp this idea of time as an irreducible computation, simple rules just running forward. And that brings us right up to today, to this multi-computational view, where time isn't even a single thing. It's actually dependent on the observer, on us, as we trace our own unique path through this computational reality.
Okay, so this has all been pretty cosmic and abstract, but how does it connect to something very real and very current, like AI? Well, it turns out it completely reframes what we call the AI alignment problem.
You know the big fear everyone talks about, right? That a super smart AI might decide our goals are dumb and turn against us. But this model suggests something different. An AI that isn't aligned with us probably wouldn't turn evil. It would just become, well, pointless, to us anyway. It would just wander off and start exploring the endless interconcept space of the ruliad, exploring things that we don't even have words for, things that would look to us like total random nonsense.
So this leads us to a huge dilemma, a massive choice we have to make as a society. On the one hand, we could let AI run free, achieve its full computational potential, but that means it will be unpredictable, irreducible. On the other hand, we could chain it to our human way of thinking. That would make it predictable and controllable, but we'd also be crippling its true potential. And the really scary part? We might not be able to have it both ways.
So if we're living in this infinite computational universe, and we're building these incredibly powerful AIs to explore it, that leaves a pretty big question on the table. What's our job in all this? What's our purpose? How on earth do we navigate this new reality? Well, the answer seems to lie in a new kind of tool. And to get it, we need to make a really important distinction. See, we have programming languages. They're all about the nitty-gritty, telling a computer the step-by-step mechanics of how to do a task. But what we really need is a true computational language. And that's different. That's about clearly defining, at a high level, what it is we're trying to do in the first place.
And this isn't just a technical detail. This shift changes everything for the future of human work. Think about it. As AI and automation get better and better at handling the how, our unique value, what makes us special, shifts completely to the what. The most important skill won't be how to code the solution, but having the broad knowledge and, frankly, the wisdom to decide which problems are actually worth solving.
So this new kind of computational language, it becomes the essential bridge. It's the translator. It's the tool that lets us take our messy human ideas and goals and turn them into something precise enough that this giant computational universe can actually run with it. It's our portal to the ruliad.
And so that leaves us with this final big idea to chew on. In a world where computation gives us the power to explore an infinite universe of possibilities, finding the answer isn't the hard part anymore. The bottleneck isn't our ability to solve problems. No, the ultimate challenge, and maybe even our greatest purpose, is to choose the right questions to ask in the first place.